again, and welcome to this week's Cribl Weekly demo on filtering out duplicate and extraneous events. Before we jump in, I just wanted to take the time to introduce myself to those of you that I haven't met. I'm Desi Gavis-Hewson, and I'm the Sales Development and Sales Enablement Lead here at Cribl. Prior to being here, I led the National Sales Development Team at co-working powerhouse Industrious. And before that, I was on the sales team at an ad sales enablement company called Media Radar. I also worked at Trello for a while and helped build out and scope out their sales development role there. So my path to Cribl is a little non-traditional for sure. And I've been in a few different industries in my career. I think ultimately, though, it was a no-brainer for me to come to Cribl just because I love and I'm good at matching people with tools that give them more flexibility and choice in their business. And that's really what Logstream provides. So lovely to meet you guys. Here's what to expect on today's call. So almost every week, holidays are a little weird right now, so we're gonna skip the next couple of weeks here, but almost every week we'll be doing a demo of Cribl Logstream and walking through specific use cases in the product. So first I'll do a quick introduction to observability pipelines and Logstream in general for those of you who may not be as familiar with us or what we do. From there, we'll move into a full demo of Logstream. We'll talk through the specific use case for that week. Obviously, this week, that's going to be filtering out duplicate and extraneous events from your environment. And then you'll have the opportunity to ask some questions of me regarding the product. Okay, so global data, as you guys probably all know, is growing at a 25% compounded annual growth rate. And I think everyone in the world understands this to some degree, right? So take being in a global pandemic, for example. Rather than our business meetings happening in person, they're happening where? Here on Zoom, right? And Zoom's generating data. So even if you think about it from a non-technical perspective, it's really easy to see that data is growing astronomically. By 2025, enterprises are going to be managing about 2.5x more data than they were in 2020. So the amount is growing, but there's another problem, right? Logging systems are already at capacity. I talk to enterprises daily with costs in the millions when it comes to licensing. On top of that, you do get inadequate data retention in some organizations. When your logging system's reaching its limits, a lot of people think that they have no choice when it comes to dropping data that they'd really like to keep around. And then kind of going back to the licensing costs, the infrastructure required to store that growing set of data can cost as much or more than commercial licensing costs. So more data also means you need more CPU dedicated to analyzing it. And for a lot of our customers, I think the added infrastructure costs can be in the tens of millions of dollars. It gets really expensive. Lastly, environments are getting super complex. So you have your time series databases, you got your data lakes, your cloud data warehouses, and each of those has its own agents and its own ingestion pipelines. It gets really tough to manage it all. So how do we solve it, right? An observability pipeline solves all of these problems. And our product, Cribl Logstream, helps teams implement an observability pipeline without replacing any existing tooling. So with Logstream, you can route data to multiple destinations, including cheap object storage, right? So this is ideal for organizations who have maybe multiple teams and different tools that all need the same data, or for anyone looking to cut licensing costs by leveraging cheap object storage. You can replay data from object storage. So once it's in the storage, you can get it back at any time. You can reuse investments in your data collectors for new use cases, secure data. You can enrich data in flight with additional context. GeoIP enrichment is a common use case for Logstream. And then you can also move workloads from batch systems to the stream, which reduces some of the infrastructure needs that we discussed earlier. So the very first thing an observability pipeline does is act as essentially a universal receiver of machine data. So a universal receiver basically consolidates all the handling of your industry standard protocols like syslog. It receives HTTP traffic directly from applications, and you can receive data from metrics agents and log shippers. The next thing the pipeline does is serve as a universal collector. So in a lot of enterprises, collecting data from data lakes, event buses, or from other log analytic systems are bespoke pieces of software, right? They're each their own thing with limited connectivity. A lot of times they're built for one particular data flow. So the observability pipeline allows you to collect data from APIs or from other destination systems, maybe that the pipeline initially delivered it to. And then the pipeline also allows us to connect any of the sources to any of the destinations in our environment, right? So it allows us to send, for example, APM data to a log system or collect from a data lake and deliver that to a time series database. Observability pipelines basically allow us to insert in the middle to redirect that data to a more cost-effective system of record. What that means is by storing full fidelity data in cheap object storage, you can then onboard all the data into your data lake. Then from the system of record, you can replay it at any time, like I mentioned before, into any system of analysis you want, like a log analytics tool, a data lake, or a time series database. And then lastly, from our position, right, and sitting right in the middle there, we can easily eliminate any noisy data that's not providing value or providing little value in your log analytics tool or time series database. So there are a number of things an observability pipeline does need to address, though, above and beyond just that reliable delivery of data. The first thing is protocol support. It's got to work with the stuff that you have already deployed, right? Your existing deployed agents. It obviously needs to receive from industry standard protocols. It's got to collect from maybe some existing observability or security systems that you already have in place. The second thing that it needs to address is the many data shapes that you might have. So getting data from several different systems can be very unstructured. Logging systems can have tens of thousands of data shapes and formats, and we need to support many nested structures, often in these more complex environments. And then the third thing is just scale, right? Typical event streaming pipeline is going to move terabytes a day. Again, I talk to organizations that need to move, tens of petabytes a day in their log pipeline. So implementing something like Cribl is going to give you a lot more than just a pure event streaming. So key takeaway here is that Cribl helps companies to implement an observability pipeline to route security and machine data wherever it has the most value. That's going to help you slash costs. It's going to improve performance and essentially just help you get the right data where it's needed and the formats required. With Logstream, you effectively can reshape, reduce, or route the data so that you remain compliant and that you get the insights you need in the most cost-effective way possible. So it's all about really that optimization of data. So next, I want you to see the product. I had my colleague, Matthew Pike from our solutions engineering team record a walkthrough of Cribl Logstream, and I will play that now.
All right, we'll click on our worker groups and we'll go into our logs worker group. Now here you can see our list of routes, 1 through 12. The ordering of the routes matter because as an event comes in, it's processed from the top to the bottom, kind of like a firewall rule set. So we'll expand one here to take a look at it in a bit more detail. We have the route name, Palo Alto Firewall Traffic. We have the filter. In this case, it's matching source type to PAN traffic, the name of the pipeline that we're going to be using, the output destination, description, and the final flag. So what the final flag is for is if it's set to yes, that means the event, once it matches this particular filter, is sent down the pipeline for processing, but the event doesn't continue on to the rest of the routes, 3 through 12. If the final flag is set to no, then a clone of the event is sent down this particular pipeline, and then the original event continues on for further processing. All right, let's talk for a moment about the filter expression. The filter expression is a JavaScript expression, so you can be as complex as you need to be. So long as the end result it evaluates to true or false, then the route knows how to handle that particular event. So if it's true, it goes down this pipeline. If false, it goes down and is continued to be processed. All right, let's look at another route real quick. In this case, it's the archival route. The filter expression is set to true, which means match everything. The pipeline is a pass-through pipeline. It literally does nothing. And it's sent to S3 for a destination. And S3 is cheap mass storage. So it's pennies on a dollar to save something to S3 versus, say, into Splunk. Now, any event that reaches this particular route is backed up, cloned to S3. You might recall our Palo Alto firewall here was a final flag set to yes. So this means the event isn't actually reaching the archival route in this instance. So we can fix that pretty easily. We can just grab this route, drag it above the other one, and click Save. And now the Palo Alto events are also getting cloned to S3. So we've got a full fidelity copy of everything sent to S3 for, again, cheap storage. Next, we'll dig into a particular pipeline and go into it in some detail here. Expand trim big JSON. And we can see the filter expression is index equals Cribl and source type equals lambda. And the pipeline itself is trim underscore JSON. All right, so we can see this particular pipeline uses two functions, a comment and a parser. It's always a really good idea to include a comment at the start of your pipeline with who created the pipeline and what the expected outcome was, and any other details you think would be pertinent. All right, we're going to start with a capture. And we can see here the filter expression was carried down from the route we clicked on the pipeline from. And when we click capture, we can choose how many seconds or how many events. We'll leave it as default for 10 and 10. And it's pulling these events off the wire. And now we're going to click Save as Sample File, and this saves it to a sandbox file we can try out different scenarios on without impacting our production data. Once we click Save Sample File, we open the sample in our preview pane here, so we can take a look at the data. So as we look at the JSON object, we can see a couple of things. We've got headers, 20 items, multi-value headers, 20 items. So these are in fact duplicate fields with duplicate data. So we can get rid of one of those and save some space. Also, we have fields that have null values, so they're providing no benefit to us. We're just using up system resources by sending the field name down with no actual value to it. So we use a parser function to make some changes here. We're going to do a reserialize on the JSON object. So we're opening the object, making changes, and then wrapping it back up. And we can work against a few different types here. We've got delimited values, key value pairs, common and extended log file formats, and CSV. We're going to be making our changes to the underscore raw field. We're going to be getting rid of multi-value headers, and just because I'm not particularly fond of it, we're getting rid of the request context as well. And we can see here in the fields filter expression, value not equal to null. So this is saying only keep fields that have a value. So now we can click on out and see the end results here. We see that green is something that's been added new, orange is something that's been modified, and then red is something that's been removed. So we see here multi-value headers. We got rid of the duplicate headers, we got rid of these null fields, and we got rid of the request context. So what does this mean to us in practical terms? We can look at our statistics here and see a 65% reduction in the size of the event. Pretty significant savings. That's great. Okay. Now, I just got a text from my boss, and he absolutely loves the request context field, so he wants me to add it back. So we can just click X, click Save, and we see that it's added right back. So what does that mean to our statistics now? Still a 45% reduction. Still pretty great. And this isn't, just a reduction in this event. It's less data going across the wire, less data being processed by your system of analysis, less disk space being used, etc. So you see a savings all the way down. It's So this is just one of several ways we can help reduce data going into your system of analysis. This one works on the fields of an actual event, but we can also drop events as well. Let me just explain a couple of those real quick. So we have drop. The drop function will drop anything that matches the filter. So perhaps you have the word debug in the comment. We can get rid of any event that matches that. And we've got suppress. Suppress is a function for volume reduction by volume over time. So say I'm getting 100 events in a minute that tells me everything is okay. We might just want 1 or 5 instead. So we can do that with suppress. Then we have sampling. Works against a particular data set. Say you want to keep 1 out of every 5 or 10 and let those through and drop the rest. And finally, we have dynamic sampling. Dynamic sampling is an algorithmic way of saying if a particular type of event is low in volume, keep all of them. But as it reaches a certain threshold, get more aggressive in dropping them. So there's a few other ways we can make some savings on your system of analysis. And there's a number of different functions you can use to build pretty complex pipelines. All right, next let's look at some enrichment using a different pipeline. So we'll go back to our routes. And this time we'll be working on the firewall GeoIP enrich pipeline for the Palo Alto firewall traffic route. So click on the pipeline. You can see in this one we've got some function groups. So we've got 1 through 5 does some extraction and reduction. And so you can kind of create these groupings of functions to make it easier to understand what a particular group of functions is doing. Again, you should always have your comments in there to make it clear when you come back to troubleshoot later what it is you were trying to do. In this example, we're going to be using a previously defined capture file. So we'll pull that up. We can see there's a lot of different fields, comma-separated values in this logging data. So we'll want to extract those fields out of the CSV and put them in the body of the event and pull them out of raw and get a clear list of all of the fields and what their values are. So we can use a parser function to do that. And it'll pull out all of these various field types and then put them into the body of the event. So we can click on out to see the end results of that. Now this is going to make your event size bigger. You probably wouldn't do this in a real environment. For the purposes of demoing what you can clearly do with the parser function and building up these fields is why we're doing this way. So you can see now we've got all those fields nicely in there and we can dig a bit deeper. All right, let's look at a way we can add some enrichment to your data. We're going to do a GeoIP function. GeoIP does a lookup against a MaxMind GeoLite 2 city database. MaxMind is the company in charge of keeping the mapping of geospatial information to IP address. We're going to look at source IP and destination IP. And to do this lookup, it needs to be an internet routable address, obviously. So we've got our destination IP address here, which is internet routable. And we can see here the city name is Boardman, Oregon. It's beneficial to do this type of enrichment at the time the event passes through Logstream before it goes into your system of analysis. That way, if you need to look back due to a security event of some kind, you know exactly what the mapping was at the time the event happened, rather than enriching it later when you're doing the analysis of a previous event. All right, so there's a few other ways we can enrich our data, and we'll look at one of those next. Another really cool one we can look at is eval function. And here we've got a field that we're going to add, and the value that we're adding is the result of this JavaScript expression here. So let's pop out the tool and take a look at it. So what we're doing is we've got a file of compromised IP addresses. This might be from the internet where you have a real-time blacklist, but we can do this sort of lookup on any type of data. So we're doing a lookup that says match the source IP address or match the destination IP address and either return true or false. And then we're going to be assigning that value when it comes back to the compromised field. So we can see over here, compromised false. So this particular host for this particular event has not been compromised. All right, so we have one more thing to show you here. We're going to be using a different route for this, and this is going to be looking at sensitive data. I just really want to show you really quickly what types of masking we can do. So we're going to look at the masking pipeline here. And we will expand that, and then we're going to load the sensitive data sample. All right, so this is really neat. This gets into one of the other tools that I think is really, really cool. So this is a masking rule tool. We have the regular expression match that we want to mask, and then the function, again, JavaScript, that we're going to execute to produce the value. So let's look at the pop out for that tool. All right, so in this instance, we've got a social security number. So what we're doing is we've got two capture groups. One is just social equals. The other one is the actual social address, the G2. So we're doing an MD5 hash on the social security and then returning it with the same length as the original social security. So we can see here, we've got it MD5 hashed. This is pretty cool. Another one to look at is encryption. For this particular example, we're doing an ESN number. So similar with the capture groups. In this instance, as I said, we're going to be encrypting it and then adding it back in to the ESN. Now, what's cool about this is if you install the Logstream app for Splunk, when this gets sent over onto the Splunk side, you're able to decrypt it in Splunk, and you can set access controls on it and limit who can have access to the decrypted information. So really, really cool. And this one last one here is looking for a number that is a credit card number. So we are pulling out any number that's between 14 and 16 digits. And then we're running a little helper tool against it to determine is it a credit card. If so, mask it and return it. Otherwise, return it unchanged. So we can see here we've got an order number and a credit card number. And the order number is left alone and the credit card number is hashed. So pretty cool. All right. So that is everything I wanted to show you as part of Logstream itself.
Amazing. Shout out to Matthew, by the way, for recording that video for me. He rocks. Okay, so you just saw a few general use cases of Cribl Logstream. Hopefully that's got some gears turning for you for around how Logstream can help you optimize your data. But let's get a little more specific. So I mentioned that Logstream helps cut costs. One way our customers do that is by filtering out duplicate events or events they don't need, right? With Logstream, administrators can trim licensing and storage costs dramatically just by filtering out those events. You can drop events not contributing to insights. You can sample the data. So if you have a bunch of events that look exactly the same, maybe you only need to analyze one of them, right? You can also suppress a defined number of copies of a type of data for a specified time period. So using these methods, our one customer, Autodesk, was able to reduce ingestion of duplicate login data by 25%. Similarly, TransUnion, one of our other customers, saw a 93.1% reduction in duplicate data. And then just now in that demo, right, we saw a 65% reduction. So we definitely see varying degrees of reduction with our customers. But the fact of the matter is Logstream helps you reduce the amount of data going into your analysis tool. So here's another video from Matthew to show you how that is done.
Hi, this is Matthew Pike from Cribl, and today I'd like to show you one of the many ways you can save money and resources by using Cribl Logstream to filter out duplicate and extraneous events. As the data being fed into your system of analysis grows, it's not just your storage costs going up. You also need more system resources, and licensing fees can skyrocket. With suppression, you can drop non-valuable, repetitive events before they reach the expensive analysis tier. In this demo, we'll walk through how to suppress events using Cribl Logstream to reduce data usage. All right, so we'll be using our demo environment here. Go into worker groups, and we'll be using the logs worker group. You can see the list of routes here for this particular worker group, and we'll be using number 10, which is the suppression route. It's looking for a source type equal to Nagios for the filter expression, and we're using the pipeline suppress. So we'll drill down into the pipeline. You can see here it's using three functions: comment, regular expression, extract, and suppress. It's always good to use comments where you can, especially starting a pipeline with a comment with the author name, what the expected output is, etc. It keeps you from forgetting what you were working on when you come back to it later, or if somebody else is taking it over and making changes to it. All right, so the second function here, regular expression extract, filtering again on the source type equals Nagios. Then we're doing some regular expression capture groups here, and we're creating a field called double_host and one double_state. So these named capture groups, once they match something, it creates fields that are added to the event. Just as a side note, anything with double_ for a field name does not get passed through to the final destination. Logstream strips those out. They're kind of considered internal fields to Logstream. So it's a good way to test various scenarios by adding double_ fields to your event, so you know they'll be stripped out at the end. We're going to be working on the raw source field in the events samples that we have here. We'll pull up in a second. So here we have the suppress function. So the suppress function is filtering on three specific things. Again, source type equal to Nagios. There's a field double_host that has a true value, and a double_state field that has a true value. So if that is matched, then we use the named capture group field names, double_host and state, to create this key expression that we match on to find events to filter. All right, so once the double_host dash double_state is matched in an event, we allow one out of every 60 seconds. All right, so now let's take a look at this in practical terms. We'll pull up our sample file. These sample files are a great way to test things out. They're sandboxed. They allow you to remove fields, remove events without impacting your production data. So they're very handy that way. All right, so we'll pull this up, and it brings us to the In tab. So you can see our list of events here. And if we click on the Out tab, this then applies the functions against the events. All right, so we can see here, we've got some events that have been suppressed. And here's another event and more suppressed events. All right, so what does this mean as far as impact to our cost savings and resource savings? We can look at the basic statistics here. We see a 96%, almost 97% reduction in the number of events. That's awesome. So this is saving you money in system resources, licensing, processing, everything. This is really great. So this is one example of a way you can save some money and resources with Cribl Logstream. We've got a lot of different ways that we can help you do that, and we'll be making more videos for those. I really appreciate your time and attention today, and please reach out with any questions you might have. Thank you very much.
Amazing. And that is that. I am happy to take any questions y'all have at this time. Please use the Q&A feature here in Zoom to do that now. I will wait a few minutes for some questions to roll in. Okay, looks like we have one here. Someone asks, what options does Logstream provide around configuring the info to filter? Okay, so in Logstream, you can use a simple filter expression, just like we saw in the demo, to reduce the data going into your analysis tool, right? So all of those filtering options can be configured based on, meta information, right? Such as a host name, source type. It can be configured based on log level, can be configured based on content extracted from the events, or any combination of those things. So it's very flexible in that way. Let's see. Okay. I don't see any other questions coming in. And so we can go ahead and end it. If you guys do think of any other questions, feel free to reach out at any of these email addresses listed here. I'm also available. My email is desi@cribl.io. Always happy to answer any questions that you might have about Cribl, about Logstream, or just anything. Sports. I love sports. So yeah, feel free to reach out. Thank you so much for coming to the very first Cribl Weekly demo, and I will see you guys at the next one on January 6th. So have a happy holidays if I don't talk to you or see you before then. And then, I'll see you in the new year. Have a great one, guys.